Yeah, very happy and a warm good morning to you all children. Now we are going to continue the chemical effects of current with the of the previous week, and this is the chapter part 2. Last week we have seen about the conductors as solid conductors, iron, aluminum, nickel. All these are all solids, and we have tested by means of a testing device. They are very good conductors. So in the similar manners, can liquid also conduct electricity? That is what we are going to do in today's lesson. So learning how the liquids are conducting. So whether all liquids conduct electricity. So if a liquid is not conducting electricity, what can we make it in order to conduct electricity? So these are the various topics which we are going to discuss it now. So listen to the lessons very carefully and understand the lesson and listen to the slides repeatedly till you understand the concepts. Okay children, now we will go into the lessons. Yes children, we are going to see now, do liquids conduct electricity? So we have seen that solids conduct electricity, and those materials which conduct electricity we call it as conductors. And among solids, copper, iron, silver are the materials which are very good conductors we have seen. Now let us discuss whether liquids conduct electricity. So see to the slide. Not all liquids can conduct electricity. However, some of them can be regarded as good conductors of electricity, while others as poor conductors of electricity. Water containing salts and minerals dissolved in it always conduct electricity. Distilled water, which does not contain any salt, cannot conduct electricity. Any solution of acid or a base can be also regarded as conductors of electricity. So some of the materials are being taken here and they are tested for their conductivity. And after the test, the list is being given here in a tabular form, and you can see that tap water, then lemon juice, cooking oils, milk, then soda compounds are found to be good conductors, whereas the other liquids are poor conductors. So you can test it by a tester, which we are going to see later now. Children, let us see how the liquids are able to conduct electricity. What is the chemical reason behind the conducting of electricity? We will discuss it now. Different substances, when mixed in water and electricity is passed through them, can break apart and form positive and negative particles, which are called as ions in water. These ions can pass electric current through them. The more is the number of ions in a liquid, the better conductor is it of electricity. That is why distilled water is a poor conductor of electricity, but salt water is a good conductor of electricity. However, many compounds do not form any ions on mixing them with water, and therefore they are poor conductors of electricity, such as sugar water, oil, and alcohol. Now let us design a tester for the testing of conductivity of liquids. You would have seen a picture in the previous slide, and that is the tester which gives us the result whether the liquids are conducting or non-conducting. A tester is a piece of electrical equipment used to check the presence of electric current. It is usually a conductor with a LED or a bulb to indicate that the current is present in the circuit. If the bulb glows, then the liquid is the conductor. If the bulb doesn't glow, naturally the liquid which you have taken is not a conductor. So let us see one by one what are they. Conducting liquids. Liquids conduct electricity too when there are salts dissolved in the liquid. Most liquids that conduct electricity are solutions of acid, bases or salt. The acid, bases and salts, what are they? Acid, bases are chemical substances that dissociates to form ions when dissolved in a solution. Therefore, they are good conductors of electricity because of the presence of the ions. Salts. Salts when dissolved in water also conduct as they release positive and negative charged ions. Conduction of electricity in water. Distilled water is a bad conductor of electricity because the absence of dissolved salts and minerals. Water starts conducting when acid, bases or salts are dissolved and release ions which conduct most of the liquids as applied to. Here is a tester for testing tap water and distilled water. So when tap water is taken first, you can see the illumination of the bulb. The bulb glows when connected to the circuit as shown in the figure. It means that the liquid is a conductor and makes the bulb to glow. Whereas in the case of distilled water, we can see the bulb remains as it is and it doesn't glow at all. It means that distilled water is a poor conductor of electricity. Distilled water is a bad conductor of electricity because of the absence of dissolved salts and minerals. So the bulb does not glow. Water starts conducting when acid, bases or salts are dissolved and that releases ions which conduct when a potential difference is applied. Hence, the bulb glows in the case of tap water. Children, let us discuss some of the important terms in the process of electrolysis. What is electrolysis? The effect in which components of a compound get split due to passing of an electric current through it is called electrolysis. What is an electrode? An electrode is a conductor of electricity that can carry electric current into nonmetals and other poor conductors of electricity. What is an electrolyte? A solution that breaks into ions on passing electricity through it is called an electrolyte. Electrolytes are used in the process of electroplating. What are anode and cathode? The positively charged electrode is called anode and the negatively charged electrode is called cathode. What are anions and cations? An anion is a negatively charged ion and a cation is a positively charged ion. So these are the various terms you have to learn in the process of electrolysis. When you are learning, just see to the diagram mark. If it is a cathode, see to the diagram where the cathode is. Now let us see the electrolysis of water. You all know that water has a molecular formula H2O, two molecules of hydrogen and one molecule of oxygen. When electric current is passed through water, it splits up into hydrogen and oxygen. This is called electrolysis of water. When electric current is passed through water, oxygen gas bubbles are produced at the electrode connected to the positive terminal of the battery, and hydrogen gas bubbles are produced at the electrodes connected to the negative terminal of the battery. Now let us discuss about some of the uses of electrolysis. It is used in industry for the production of many metals and nonmetals. It is used to coat one metal with another, which is also known as electroplating. It is used in refining of impure metals, also known as electro-refining. Children, now we will pass on to the various effects of an electric current. The various effects of electric current can be classified into four: heating effect, mechanical effect, magnetic effect, and chemical effect. So let us see what is it one by one. Heating effect. Electric current causes heating of the electric equipment. For example, the filament of a bulb gets heated up due to electric current and therefore it glows. And you all know that the electric iron which you use to press your uniforms is working on the principle of conversion of electrical energy into heat energy. Then mechanical effect. Electric current can lead to generation of mechanical energy in appliances. For example, fans and motors work due to this effect, that is the mechanical effect. Then magnetic effect. Electric current can give rise to magnetic field of a substance. Then lastly, chemical effect. Electric current can lead to the production of chemical energy or chemical reactions. Now we are going to see an important process called electroplating. What is this electroplating? The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. Example, for electroplating of copper on an object, the object is dropped in acidified copper sulfate solution and connected to the negative terminal of a battery. A copper strip is dipped in the solution and connected to the positive terminal of the battery. When electric current is passed through the copper sulfate solution, copper sulfate dissociates into copper and sulfate. The free copper gets drawn and gets deposited on the objects connected to negative terminal. From the other electrode having copper strip, an equal amount of copper gets dissolved in the solution. Thus, loss of copper from the solution is restored and the process keeps on going. Children, now let us pass on to the various applications of electroplating. Medical equipment is made up of nickel, which is harmful to the human body. Hence, to avoid it from coming in contact with our body, a coating of platinum or gold is applied on the surface of nickel. Many kitchen equipments, bath taps, parts of car, etc. are covered with chromium coating. Chromium is an expensive metal, hence the objects are created with the cheaper metal and chromium coating is provided over it. Thus, to bring a shining over the objects and prevent them from corrosion, chromium coating is used. Jewelry makers often make ornaments of less expensive metals and provide a coating of gold or silver upon them. The tin cans that are used to store food are actually made of iron and hence a coating of tin is made on them. Iron can easily react with food and spoil it. However, tin prevents the food from getting reacted with iron and therefore helps in preventing it from getting spoiled easily. Bridges and various parts of automobiles are made up of iron because it provides tin. However, in order to prevent iron from getting rusted, a coating of zinc provides and on the surface of the iron, which is also called as galvanization of iron. Children, now we will pass on to the various effects of an electric current. The various effects of electric current can be classified into four: heating effect, mechanical effect, magnetic effect, and chemical effect. So let us see what is it one by one. Heating effect. Electric current causes heating of the electric equipment. For example, the filament of a bulb gets heated up due to electric current and therefore it glows. And you all know that the electric iron which you use to press your uniforms is working on the principle of conversion of electrical energy into heat energy. Then mechanical effect. Electric current can lead to generation of mechanical energy in appliances. For example, fans and motors work due to this effect, that is the mechanical effect. Then magnetic effect. Electric current can give rise to magnetic field of a substance. Then lastly, chemical effect. Electric current can lead to the production of chemical energy or chemical reactions. So, what are the effects of electric current? Chemical effects of electric current. When electric current is passed through a conducting solution, it causes chemical reaction. This is called chemical effect of electric current. Chemical effect of electric current may cause formation of gas bubbles at the electrodes, deposit of metal on the electrodes, change in color of the solution. Now, let us see the solution for some of the questions which are very important on this lesson. When the free ends of a tester are dipped into a solution, the magnetic needle shows deflection. Can you explain the reason? Answer. The deflection of the compass needle shows that current is flowing through the wounded wire and hence through the circuit. The circuit is complete since free ends of the testers are dipped into a solution. The solution is certainly a conducting solution. This is the reason why the compass needle shows deflection. So, the deflection in the needle means there is a flow of current in the circuit. When there is a flow of circuit in the current means the liquid which you have taken must be a conducting liquid. That's very simple. The next question. Name 3 liquids which, when tested with the manner shown in figure 14.9, may cause the magnetic needle to deflect. Liquids like lemon juice, salt water, and vegetable oil allow electricity to pass through them. Hence, these liquids can be used as in the electric effect of current. Yes, children, by this we come to the end of this chapter. So this chapter is completed in all respect. Now, after you go through the slides as many times as you want till you understand, go through the textbook and read the lesson completely. So the homeworks I will give you separately. So we have come to the end of today's learning session, and we will meet next week same time. Until then, bye from you children. Bye bye.